Now we are going to start the second part, and that is Dobereiner law of Traids, then cylindrical periodic table, and Newland law of Octaves. Let's take one by one. First is Dobereiner law of Traids. Dobereiner law of Traids. As the name suggests, something of triad. Three is there. Some three things is there. Now what three is there? What the law says that. So if we take three elements in increasing weight consecutively, then the mass of the middle element or the weight of the middle element will be mean mass of first and third. जब भी हम तीन का ग्रुप ले ले इंक्रीजिंग एटॉमिक वेट में, तो जो मिडिल एलिमेंट होगा वो हमेशा मीन मास ऑफ फर्स्ट एंड थर्ड होगा. एक एग्जांपल लेते हैं, जैसे हाइड्रोजन 1H1, हीलियम मालूम नहीं मिडिल में है, मालूम नहीं, और फिर आता है लिथियम 3Li7. देयर आर वेरी आइसोटोप्स. हाइड्रोजन के कई आइसोटोप है, इसके भी आइसोटोप है. तो अगर हम इन तीन की बात करें, because at the time of Dobereiner there was no discovery of isotopes and isobars, so इसलिए हम उसकी बात ही नहीं कर रहे. हम तो एलिमेंट की बात कर रहे हैं कि 1H1 और 3Li7. if we add the mass of first and third, add it, divide it by 2, we will get the mass of the middle element, that is 4. And this is 2He4, and when we analyze the element in the nature, we found true. So, according to Dobereiner law of Traids, when three elements are taken consecutively in their increasing atomic weight, the mass of the middle element will be the mean mass of first and third. Now comes cylindrical periodic table. This was given by a scientist known as A.E.B. de la Courtois. Courtois. He was commonly known to be A.E.B. Condell also. A.E.B. Condell. So now, this A.E.B. Courtois, he said that if elements are to be arranged in a cylindrical form, then we will have a helical arrangement in this cylinder. Above helix we will have metal, so non-metals. Below helix we will have metals, and on the helix we will be having metalloid. So these three things will be there. And why this is known as telluric helix? Now this is commonly said telluric helix. Telluric helix. Now why it is said to be telluric helix? Because this helical arrangement ends at tellurium. वो टेल्यूरियम पे जाकर के एंड हो जाता है, और इसीलिए हम इसको टेल्यूरिक हेलिक्स कहते हैं. Right? So once again, according to this, if the elements are arranged on a cylinder, then there occurs a helical arrangement, above which are non-metal, below which are metal, and on which are metalloid. And this helix ends at tellurium, and therefore it is also known as telluric helix. Now we come to Newland's law of octave. It was given by Newland Alexander, and Alexander Newland. And according to him, he said that there is a musical instrument harmonium where there are 7 notes, and after 7 the 8th is again the same. That is do re mi fa sol la, do re mi fa sol la. Now do re mi fa sol la. Or sometimes what happens when the question comes. Now this will be the question of advanced level type or toughest question. This Newland law of octave is based upon, then there might be a 7 notes sa re ga ma pa dha ni si pa dha ni sa is there, and we can confuse from that. But remember, this Alexander Newland was not an Indian, so he doesn't know about sa re ga ma pa dha ni. He knew about do re mi fa sol la. Now these are the tones and overtones over harmonium. हारमोनियम पे जो बनता है वो ये है, और जैसे ही लाटी हुआ फिर डो हो गया. So after every 8th element the properties are repeated again. The elements are increasing atomic weight, and at this time again the elements were discovered 63. 63 elements were discovered at this moment, and rest were not discovered. So once we can conclude that Newland's law of octaves says that whenever the elements are arranged in increasing atomic weight, the properties of elements reoccur after every 8th element. Got it? Yes.